Hey, it's Monaco.
Hey,
And Milks.
what's that?
Homework numero ocho, acid-base titration calculation. So this is where the maths comes into play. Aside from when we were doing the logarithm pH stuff in the POGO,
Yes.
this is the only other part of the unit where math comes into play.
Plug and chug.
Plugging and chugging. So if you got your algebra, bro, you're good.
What? Ooh, animation.
No, well,
Sorry.
here it is. Neutralization reactions can be used to find concentration of unknown acid or base. If I got an acid over here and a base over here, I know that they'll react to neutralize.
Yes, we studied that.
And if I know that this is like 10 molar, and I know how much I got, and I don't know the concentration of this, you can do something very carefully.
That's called the titration.
To figure out what the concentration of the unknown was. And that's what this whole lab and notes is about.
Sure, I'm going to step to the board because you got this rocking, right?
Yeah.
So what's this? What's A talking about, Monica?
This is what? That is talking about the chemical that we're going to titrate. So the acid solution is put into the flask. We don't know the concentration of the acid solution. We know how much we've got, though.
We really want to know how much.
You have to know how much you're going to use.
So in here, I'm going to have a known amount of acid.
Typically 10, 15, 20 milliliters of acid. We don't know the concentrations. We don't know. It's X molar.
And here it goes.
There it is. So it's sitting in there. And then you've got this thing called a burette. And it is basically a graduated cylinder with a valve on the bottom.
Upside down.
Yeah. So when you're in the lab, you're going to see that at the top, it says 0.
Okay.
And at the bottom, it's going to say like 50. Okay. Which means that when you turn the valve on the bottom of the burette,
That's here.
the base that you've loaded into the burette is going to drip out towards the bottom. And as it does, the liquid level is going to drop, and it's going to actually count for you how many milliliters you have added. Okay, so the difference between your starting and your ending amount in your burette is the amount of base that you've added to your acid.
And I see a difference in between the colors of the liquid. So why did they change colors?
Because there's an indicator.
An indicator changes colors.
Exactly, to tell
Based on
you
a change in pH.
when the acid has been completely neutralized by the base.
There you go.
And that's how you know when you finished. So when you finish a titration, you'll know how much base you used. You'll know the concentration of the base because we'll give it to you.
Right.
You'll know the volume of the acid that you had put in the flask at the bottom.
Because you measured it.
And the only thing you don't know is the concentration of the acid. But guess what?
Plug and chug.
There's a calculation for that.
Yep.
So that's what we are going to do with this homework. We're going to show you those calculations, and that's what's
Excellent. And then the last piece is, right, is that pink. We're going to find out when we do the lab, right, the lightest pink possible, and that'll be the competition.
Right.
Because you get a dark pink, and now you added too much.
Yes, exactly. Because that's the thing with acid-base titrations. You can go past the end point.
Yes.
You'll add too much base, and you'll think, well, it's done.
It actually makes a really cool dark magenta, which is a mad wavy color.
Once you've got your results,
you can play with it.
Then we'll let you play with adding more base and see how dark you can get.
Right.
But
So we're going to add a base that has a known concentration, like you said, with it to an acid that doesn't have a known concentration or an unknown. That's basically what a titration is.
And you want to do it carefully. So you will want to drop the base into the acid very slowly towards the end.
Drop the base. Yeah. So we're going to measure the amount of acid first, like we said.
Put it in a flask.
Yep. Then we're going to use the titration calculation, of course, to figure out the molarity of this unknown acid, which is the next piece.
And the results of a titration, like I said, you're going to have 3 values: the volume of the base, the concentration of the base, and then the volume of the acid that you measured.
2.
And you're not going to know the concentration of the acid. Well, I said you're counting wrong.
Oh, yeah.
We'll send them back down to elementary. It's okay.
We have that.
We know the volume and the concentration of the base.
Yeah.
We know the volume of the acid. We don't know the concentration of the acid, which is what you're going to solve for. Did I say it right that time?
I don't know the camera.
Oh. So
can I go to the board again?
Yes.
Good.
Titrations. Guess what? It's a calculation from table T. Okay.
Oh,
it's really easy, as a matter of fact. You multiply the molarity, the concentration of the acid, that's Ma, times the volume of the acid, Va. And that's got to equal, if you've neutralized it perfectly, the molarity, aka concentration of the base or hydroxide, and the volume of the base, which you measured as it dripped out of the bottom of the burette.
All right.
So example problems.
Yes.
What is the concentration of a solution of HI if 1/2 of the liter is neutralized by 0.3 liters of a 0.4 molar solution of KOH? So I think we should figure out which one's the acid or the base first.
Ooh. Acids have OH in them.
Wrong.
Oh, I'm really not having a good day.
Acids have hydrogen ions at the front of their chemical formula.
Man, you're
So
good at this.
HI is our acid. So
All right,
we
so
know the acid is in green,
And I'm given
0.5 liters. So we know the volume of the acid.
5 liters
Perfect.
of acid. Okay.
Now we know that our other chemical must be the base, and it's got the OH at the end of its formula. So there's another dead giveaway for an Arrhenius base. Now we know the concentration and the volume of the base. So 0.4 molar is the concentration, the molarity of the base, and 0.3 liters is the volume of the base. So now all you do is you set up your equation, MAVA. Oh, Mr. Milk skipping steps, but it's okay.
Yeah, I don't like to write the equation again.
He doesn't like writing the equations. I do. Please do write the equations over again. He has inserted the variables that he knows into the given equation, leaving the unknown as the MA. Now all he's doing is solving for MA using algebra. So the molarity of the acid in the scenario is going to be equal to the product of 0.4 times 0.3 divided by 0.5, and that's what you have got.
Yeah, you're going to come up with the answer for that, by the way.
And all of the practice examples follow this exact same suit. You're going to be given 3 of the variables.
Yes.
You've got to find the 4th.
Plug and chug.
I guess maybe the hardest part really
Is the
will
reading
be
comp.
to reading comp to
Do you know
understand.
which one's the acid, which one's the base?
There it is.
Is molarity concentration or is the liters concentration?
Right.
You put in those places, things in the right places, you're good.
No unit conversions in there. I don't think
No.
we threw any curveballs.
No.
The volume could be in milliliters or liters. Doesn't matter.
As long as they're the same on both sides, you're good.
Concentration is always going to be in molarity because
For our part.
that's what you have to have for acids and bases.
Yep. Parts
And-
per million is not going to be it. That's not concentrated enough for us.
No, I mean, if you had both units and parts per million, your answer would work out, but we don't care. We
Ever
want
measured
molarity.
Yeah, that's way more concentrated than parts per million would allow. So
Way more
I think that's it. I think we're out.
I think. See you.